In this module, we're shifting from predicting continuous values, like house prices, to classification modeling. Today, Jasmine, Ryan, Lena, and Carlos are brainstorming how to help their client identify high-value sales based on past housing data. Let's listen in as they discuss the next steps in building a classification model. Carlos, the project manager, oversees the project and ensures progress aligns with client goals.
Great progress on predicting house prices. Now let's shift gears and see if we can help our client identify potential high-value sales.
Ryan, the business analyst, analyzes market trends and business requirements for data insights.
That's an interesting twist. But how do we define what constitutes a high-value sale?
Jasmine, the data scientist, applies data science techniques to develop predictive models.
We'll need to dive into the sale price data and set a threshold that reflects premium properties in this market. We could consider the top 25% of sales or a specific dollar amount that aligns with luxury listings.
Lena, the Python programmer, implements the technical solutions using Python programming.
So, once we define high value, we're essentially trying to predict which houses fall into that category, right? That sounds like a classification problem.
Exactly, Lena. We'll use a classification model to predict whether a house will be a high-value sale or not.
Can we leverage the same features we use to predict the price itself?
Yes, but we'll need to analyze how those features relate to the binary outcome of high value or not high value. Some features might be more relevant for classification than for regression.
Got it. And Jasmine, what kind of classification model do you recommend we start with?
Let's begin with the logistic regression. It's a common and effective model for binary classification problems like this one. We can then explore other options if needed.
Sounds good. I'll get started on implementing logistic regression in Python.
Excellent. I'm eager to see how this model can help our company identify those high-potential properties.
In this scenario, the team discusses the shift from regression to classification modeling, focusing on how logistic regression can help predict high-value house sales. Now let's dive deeper into the concepts with some reflection questions. 1. Defining high-value sales. Jasmine suggested using the top 25% of sales or a specific dollar amount to define high value. What are some advantages and challenges of choosing each method? And how would you approach defining a high-value sale in this case? 2. Classification versus regression. The team is transitioning from predicting continuous values, house prices, to predicting categories, high value or not. How does classification modeling differ from regression modeling, and why is logistic regression suited for this binary classification problem? 3. Feature selection for classification. Jasmine mentioned that some features might be more relevant for classification than regression. What considerations should be made when selecting features for a classification model? How might feature importance change when shifting from predicting prices to predicting high-value sales? 4. Logistic regression. Why did Jasmine suggest starting with logistic regression for this classification problem? What are the key strengths of logistic regression when it comes to binary classification?